Okay, let's get started. If there's no one with a question, then let me share my screen. The entire window. If you're able to see my screen, someone to say something so that you can proceed. Okay, okay. So, from our previous classes, I think you remember what Remix IDE is. Remix is an online code editor for writing smart contracts for Solidity programming language. So if you remember, this is some of the this is where we there are some of our smart contracts that we have written here. But in today's class, we'll be writing a smart contract, a small one. Then we'll also create a front end for it for us to interact with the smart contract in the front end. Okay, and in the meantime, I created a front end so that it can be easier for us to follow along because when creating a front end using React, sometimes it can take a while. So I created the front end just right now. You see it's plainly blank, mainly just this React, how a React app starts. And here is the code base for the React. Yeah, this is everything here. So we can get started by creating a, let me create a folder called bit-kca. And inside the folder, let me create a file called counter.sol, right? And in the counter.sol, we're going to write a we're going to write a solidity code where someone is able to increment and decrement a number. We're going to write the smart contract for that and also create a small front end for it for where someone can have buttons to perform those actions. So as remember also by default, if you remember, for you to write a solidity code, the first thing you need to start with is the solidity license identifier. No, there's a license identifier and the solidity version. So yeah, let's start with that. 0.8.0. Let's use that. Then if the code is too small, you can tell me to zoom in, or is it okay? Should I zoom in or it's okay? Okay. How about now? Okay. As you've seen, I've written the license identifier, the license version that we're going to use, and the solidity version. So we'll start by writing for you to write a smart contract, you start with the word contract. Like this is the syntax of solidity contract. Then the name of the contract, let's call it counter, yeah, like that. Then curly braces. Then we'll start by, the first thing we need to do is declaring the state variables. By state variables, I mean like the initial state of the variables you're going to use. Like if you're going to use a string inside, either it's a string, it's what else? It's a string, an integer, any type. It's good for you to define it here at the top first. So yeah, we need to define. We can define it uint 256. This is the unassigned integer with a 256. Let's call it counter. Yeah, the same counter. And you can leave it blank. If you leave it blank, by default it's going to be equal to 0, but if we give it an equal sign to something, it's going to be equal to, let's say, yeah, the number like that. If you space 23, it's going to be 23, but first let's leave it blank so that you can see it's going to be by default 0 when you define an integer without a value. And the next thing we need to do now is called in a normal application, as you understand, there are reading functions and writing functions. Reading function is just receiving information from the blockchain, like even not necessarily blockchain, but any application, even WhatsApp. When someone texts you, when you read the message, that's a reading function or a reading privilege or anything you can call it. But when you text something and reply to it, that's a writing function because you're writing to the system. So in blockchain, when you interact with the reading functions, you don't incur any gas fees, but when you interact with the writing functions, that's where you'll interact with the gas fees. So let's start by defining the reading functions. So because they are really easy, reading function. The reading function that we are going to interact is called a function. It's a function that's going to get the number. Let's call it get counter. It's going to get the count of the number. Let's give it a visibility for external because it's both visible inside the contract and external, because you will be able to see it here at the side at the bottom here. Okay, let me minimize that. External, and another word is view. Yeah, and let's say it will return. Returns means we define the data type that's going to return, either the string. But if you see at the top here, uh we defined what? We defined a uint to 56, so it's supposed to return also a uint to 56. Yeah, and then we open the bracket, the square, the curly braces, and say return. We return the counter. Counter, where is the counter? This one. So if you see, well, now we're going to have a function called get counter. When you click on it, when you call this function, it's going to trigger the for us to see the counter, the count, the number of the count. So if we go to the, yeah, you will need to compile it faster. This is just a small thing that I've written, but let's just look at it. When you look at the compiling part, I've clicked auto compile, but yeah, you can compile via here, and make sure you have a green check here so that you can your code can be, that means it has been compiled successfully. But if I remove something like this is an error, so we'll have a green with a red color there, means that it has not been compiled successfully, and other types of errors. After compiling, we can go now to the deployment part. In the deployment, you can see here we are. For now, we'll start with a Remix virtual machine. This is like a local environment where you're given plenty accounts with some test nets, and you can see now we have 0 deployed accounts. So after here, you can see we have 0. We have 100 wallets and 0 deployed contracts, and each wallet has 100 ethers. So if we have select this one selected and deploy, they see that the account now has been that we have used to deploy now the contracts. There's some gas fee that has been charged, and you can see here the console here at the bottom. Where is it? Where is it? Yeah, you can see this green check here means that's a transaction, and you can come here and see we have one contract deployed, and it says get counter, and the when you get the counter, the value is 0 because we haven't defined it, but it's of overtype u into 56. But if we come here and change it to maybe 25 and redeploy again, and redeploy, yeah, we have a new smart contract deployed, and check the counter. The number is now 25. You can see here, yeah, like that. Oh, yeah, this is one of the ways you can define your initial state of your, and also you can see when, let me clear here so that I can show you. When I deploy, we have this green check, which means it's a deployment, and some gas fees has been charged. And if you come here and now call the function get counter, it's going to interact the blockchain, but it's a call function. Let me click on it. Yeah, it's a call function. There's no transaction fees. It's only calling data from the blockchain. It's not in updating it or writing on the data. So there's no transaction fees on that. So, and you can define your data type manually, like the state variable, the initial state variable of your the initial state of your state variable at the top, or you can use something called constructors, where a constructor mainly, like, before deployment it's going to ask you a question, like, not a question, but here where you'll see next to the deployment, this there'll be like a field here where you are supposed to be to specify the initial state variable of your contract when deploying. So you define it by writing constructor. Okay. Okay, as I was saying, constructors. So you define the word constructor and open square brackets and say it's a constructor is it's this type u into 56. U into 56. This is one of the most important things in writing a smart contract. Yeah, having a constructor, and another thing is called a mapping. U into 56, and have a, let's define you can have like a holder. It's called, like, I can say, like a placeholder. Let's say call it starting point. I've used underscore because it's easier trust for remembrance, but you can either use it without an underscore. Yeah, it's still okay. And after that, curly braces, and say now the counter. Where is the counter? Yeah, this one is equals to underscore starting point. Yeah, like that. So now, if you check here the deployment, you can deploy it without it having a value to start with. So right now you can see the let's someone has opened the mic. Sophia, you can mute yourself. As I was saying, even if we define at the initial state here, like a number is equals to, like, maybe something like that, but still, Sophia, please mute yourself. Okay. If you define the value of here 876, the value of the counter, the initial state of the counter, but still during deployment it will ask you another number. If we change it to maybe another number, a random number like that, and hit deploy and check the get counter, I can ask a question and see what your response can be, so that I can see your if you are we are together. If I now click on, how is it called? How is it called? If I now click on get counter, what will be the number? During the code, I had coded the value to be 876, but during deployment, I set the counter to be 234. What will be the number? If I check now, I click get counter. Anyone who knows? You can either unmute yourself and say something or type in the chat. Okay, let's just proceed then. When you get the counter, it's going to be 234. It's going to overwrite the number that you've written here by like using the number that you've defined during deployment. So it's easier to leave it blank, yeah, because it's going to be overwritten either way. So as of now, you can say we have a smart contract that can read from the blockchain. After now reading functions, we can go now next to having writing functions. Writing functions now, we can have two writing functions here. The first one is going to be incrementing function, which means it's going to get the value of the counter and add it plus one, let's say plus one, or the number that will be specified. Another one is going to be a decrementing or decreasing function, which is going to get the value of the counter minus one, or minus one, or the number that you're going to specify. This one is increasing or incrementing or increasing. So let's start with the incrementing function. So we also just use the same syntax as this, which is function. So now this is going to be, instead of now getting the number, it's going to be called increase number. You can call it increase or any word that you want. Let's call it increase. Increase the value of the counter or the number. Just for your remembering purposes, just use the words that are good, you're okay with. External also for visibility, view, and then returns. Returns, you can see here I'm writing returns with S, which means it's going to return that. But here you say return this now. Here you mean it returns, means it's supposed to return this. I don't know if you get that. This also is going to be a unit 256. Oh no, sorry. Here there's no need for you to specify the return purposes. Okay. Set the counter to, not that one. Counter to plus plus. If you remember this in other programming languages, this is like the easy way of implementing an incrementation function. We can copy the same code and paste it and use it here because it's basically the same thing. But here now, instead of plus plus, we can change it to subtract and call it decrease counter. And if we now go and deploy the number, it sounds like that, and hit deploy. Let me bring this up. Okay, clear now. We have deployed. So we see we have like three functions here. The first one is get the number. No, it's 355. It's a call function, not transaction fee that has been charged for performing this action. The next one is increasing number and decreasing number. So if we by by now we know the number is 355 because we defined it here like this. But if we now increase the number once, you see it's a transaction. If you get the number now, you can see it's 356 here. It has increased by one. If we increase it again, 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 you get the number is 359. If we decrease it again now, 358 here. You see, we have all three functions where you are able to interact with the blockchain by either increasing or decreasing a number. Uh, I'll stop there and maybe wait for some questions if anyone has any, because this is the small smart contract that we have for today, and we're going to create a front end for it. Anyone with a question? I'm going to push the code to GitHub, and I'll share the link to the code. Yeah. Any other question? If there isn't any other question, we can move to the front end. As I remember, I told you, yeah. Oh, before we move to the front end, let's now deploy this now smart contract to the main blockchain now, to the blockchain itself. You can shift now from injected provider to remix, from remix VM to either, you can either use injected provider, which it will pick the wallet that you have, which is MetaMask for me, or wallet connect, and you can show all the options of wallets if you have plenty, and they choose the one that you want. Let's go for injected provider. I think you can see a MetaMask pop up, but you can see here it's connecting with my MetaMask wallet. It's going to ask me for my password. Then it authenticates. Yeah. Let me put my password. Yeah, it has connected. So let's say it's going to reflect here. I think it's saying I have 0 ETH. Let me check that. Let's say that. Okay, I have 0.1. Okay, I think I have some. Yeah, I have some test nets. So let's see here. Yeah, you see it has reflected. I have them 0.1. But let's say you don't have any test nets. You don't have any fund, some gas for you to use for you can go to this website. It's called Chainlink Faucet. Let me send the link to this website in the chat. If you go to, let me check my balance now. If you check my balance, I have 0.1. So let's go and request for some faucets. I think you're given 0.1 after 24 hours. We're going to use Ethereum Sepolia. So you click on Ethereum Sepolia and then continue. Yeah, that's the address. Then you need to verify. It will, if it's the first time, it will ask you to verify using your GitHub account. But yeah, because I've connected, it's going to like Just ask me to verify if I'm a human being. It's taking a while. Let's wait. Let me start afresh. I think the same. Let me refresh this page. I choose Ethereum faucet. Sepolia. Okay, let me verify. Get tokens. Let me go to my wallet and wait. It's going to change here to be 0.2. They've sent me 0.1 Sepolia E. Yeah, you see it has changed. So I've been given 0.1 Sepolia ETH. So we can now go back to the Remix IDE. It's inject provider I've chosen now. During deployment, let's say use like 500, just a random number, yeah. And we click deploy. MetaMask is going to pop up. It's going to ask me to sign this transaction and pay some gas fees for the smart contract to be deployed. Let's wait and see. Yeah, and let's confirm. If I see it had been written the amount of gas fees here. You can see I have 0.241. Let's wait and see how much it will reduce by. Yeah, it does not deploy this to the blockchain. It tells you view on Etherscan. Etherscan is like the file, like the storage or the any transaction that you do on the blockchain is going to be listed on Etherscan. So if you can check here when you come to Etherscan, there they have directed us, or you can also Google Sepolia Etherscan because we are using Sepolia Etherscan. Yeah, let's wait it finishes to load. Yeah, when it is from, you see it says from my from here. Yes, it's still here from 0xc79. That's also the same as my wallet address here at the top, 0xc79. And two is going to be the is a contract creation. Yeah, you can see it here. And yeah, that means we have deployed our smart contract on the blockchain. For good purposes, you can come here to where it has been written contract and click verify and publish for you to verify your smart contract. After verify smart contract, it's going to have like a green check, a green tick, which it means like it's, I can call it like a verified. When you have a verified any account, it's either Twitter or anything, that means it someone connects legitimately you. Okay, so here you choose the solidity version that you used, single file because it's a single file smart contract, and the open source we use the MIT. So if you check here also, yeah, you can see. Let me show you what I'm doing. License identifier, which we chose MIT, and the solidity version 0.8.0. So here, yeah, we have done the same thing, 0.8.0, and MIT as a license identifier. Click continue. It will ask us for the code of the smart contract. Let's come here, select all of it, copy, then come here, paste the solidity contract code below, paste it there. Sometimes you're supposed to use an ABI, but sometimes, yeah, most of the time you need to paste your ABI also here, and you can get the ABI from here. You go to the compiling part. Down at the bottom, complete. You can see it has written ABI. ABI is like it's called in full. It's application binary interface. It helps you in now creating the front end. Yeah, you can copy it from here and paste it, but let's wait. Sometimes it fetches it from
Here are
the.
a few ways to complete the sentence. Sometimes it, general phrases, happens, feels good, doesn't go as planned, takes
Okay,
time,
wait a minute.
rains. More specific examples, takes courage to be yourself, gets lonely, hard to say no, snows in the mountains. Feels like a dream. Would you like me to provide more options or complete the sentence based on a specific context?
Okay, sorry for that. So after now, sometimes I said it. Sometimes it fetches the ABI from the remix directly, or sometimes also you have to paste it yourself. But I hope it has fetched right now. Just let's click verify and publish and see. If it won't fetch, we'll have to paste it manually or just use the contract like that. Either way, it will work. Yeah, you see, it has fetched it and we have a green check here. If we now go to your smart contract now that has been deployed, you can see on the contract part here you have like a green tick here, which means your contract has been verified and it's okay. You are able to see all the code here and the ABI. Yeah, so that's okay up to that point. Now let's go to the front end. In the front end now, here is the where is it? Here it is. This is how it looks, and we're just going to add some few buttons. But before then, after now initializing your React app, just another thing that you just need to add is install another. It's a JavaScript library for Ethereum that helps you interact with the blockchain. It's called Web3.js. Let me just Google it for you to see. Web3.js. You can go and look at its docs, and it helps you now interact with the smart contract that you've written on the front end. It's this one. You can go to the docs and check it out. Let me send the link here to. Okay, yeah, it's Web3.js. This one, yeah, that one. So after that, okay, you can come here. Let's go back to the code and let's now install Web3.js. It's installed by just writing npm I for install, or just write the full word install Web3, just like that. Let's wait and see. As it's installing, let me confirm if I was recording this session so that I can share with you. You can go to the package.json and see if we have a, yeah, it has installed Web3, so it means it has finished. Yeah, it has finished. So we can now start working on our app.js here. When you're working on our app.js, let's start by, let's just leave everything. The first thing you need to do is import the Web3 JS module. By doing like this, you say import, not like that. Web3w, import Web3w with a capital 3, capital W, and say from Web3 now with a small w. Yeah, this one. Yeah. And also, yeah, also in the during importing, we can also install the import. I mean, you can also import the use state because we're going to use it later. Anyone who's floating so far, also that I can clarify anything up to that point. Anyone who needs any clarity? Okay, we can proceed then. The first thing after now installing the Web3.js module and used it, the first we can define the contract address here now. Const address is equals to, let's go and copy it from here. The contract address is this one. Let's copy it and paste it there. Another thing we need is the ABI. Const ABI is equals to, let's copy it from here also. Let's end it with that, and yeah, those are the two. Now we can now interact the smart contract in the front end now by just having these two. We have the contract address now, like the location of the contract on the blockchain, and the types of the, you can see here we have the starting point. This is like a boilerplate of what you're supposed to use in the front end, where you get it from the ABI. You remember we wrote the starting point IU 56, the like the the how is it called, variable, state variable, and other things like a construct and other things. Yeah. So after having those two things, now let's add but let's have three buttons. Three buttons. Where can we put it? Let's remove these things here, like this up to here. Let me go and see how it looks. Let's refresh and see. Yeah, let's have the three buttons now. The bottom here. The first button. Let's have the button. Oh, it's not accepting. Button, yeah, like that. Let the first button say something like get current counter. Yeah. Then the second button can say, I mean, we're just creating the buttons for now. You can see at the front end here, we have that button here, but it doesn't have any action, so it's basically just a button for now. We have another button. And let the second button say increase counter. Then the last button can say button, let's say decrease counter. Yeah, those are all the buttons we have now, and let's finally have a paragraph. Wait, now these are the buttons. Like now, the last P for the paragraph, for where any change that is done, someone can see, and let us say the counter, and it's going to display the value of the counter here. Yeah, like that. So let's start by now writing the function are going to get the data from this. Let's see. Yeah, we have the three buttons. You can maybe do something like having a, I don't know if this will help. Having a, is it called a HR? Yeah, something like that. And also repeat it here so that you can see the difference in the buttons have some difference in them. HR, which means it's a horizontal. HR means stands for horizontal line. It's an HTML attribute. Let's have another HR here. It's a self-closing HR attribute, and we can see, yeah, it's basically, you can think it's a dot right now, but it usually stands for a line. When you have a lot of things, it's going to be a straight line. Yeah, but that's mainly for differentiation. Now let's get now to the main functionality. We have now we have imported Oh, sorry. We have imported the 3GS module. We have gotten the contract address and the ABI. And we have written the buttons, and now we have to implement now the functionality. Let's now start by creating the use state. The state for that const the state for the counter. Say counter set counter is equals to use state, and the initial state, let's set it to none. And after that, yeah, now let's the second thing after now you have installed the 3GS module. Now for you to interact with the smart contract now is initializing the web3 object for you to connect now like your metamask to your application object depending on the blockchain that you're in from the injected provider. Like the way you in Remix we connected MetaMask to Remix. But yeah, now this one it cannot. You can also connect your application you can connect MetaMask your application using MetaMask, yeah, through this function. You can do it by writing const web3 is equals to new web3. Then we say window dot Ethereum. Yeah, like that. As of now, if someone interacts with your blockchain and tries to interact with the increasing and decreasing counter, they'll have to first connect to your application, yeah, using MetaMask or any browser wallet that they have. But because you have deployed a smart contract on Ethereum, Sepolia, so supposed to have a wallet that accepts Sepolia Ethereum. We can call it that accepts Sepolia, yeah. And the next thing after that now, it's now initializing the ABI and the address. Initializing the address and the ABI. By doing that, basically here this is JavaScript, but we're using Web3.js, so it comes with these functionalities. So also const again my contract. Now you write my contract. I'm creating a state, like I need an instance for my contract here. Contract is equals to new web3 dot eth, yeah, dot contract. Then open the brackets and say ABI, comma, address. So by after defining this, it's going to fetch now the ABI from the ABI and the address from the address here. Yeah. And now you can say we are ready and set to go. For now, we're mainly writing the functions for doing these things. So it will after now performing these actions, we're going to like now see it in the front end. Now let's start by interacting. Interacting with the reading functions. If someone remembers, I talked about this in the class. Which are the reading functions? There's also reading functions, and then next thing we're going to do is now interact with the writing functions. Anyone who remembers that? Yes. Something around that? Which are the reading functions and which are the writing functions? Okay, if you don't want to say, let's proceed then. So we're going to create a function that's going to go, as we call it also in the smart contract, let's call it get counter. Let's see how we call it here. I'm seeing I kind of made an error, but yeah, we can. I used yeah. You see, I called it the wrong way, but just let's proceed like that. You can see it, I just placed an H somewhere, so let's just proceed like that. But you know it, meaning get counter. So yeah, get counter. Then say inside the get counter is going to be it's going to display the results, which is equals to await. Yeah, this is going to be an asynchronous function, but let me write it first. So I'll change my contract dot method. This with Web3.js syntax. Then write get counter brackets, and then get counter is the name that we use, and then you write dot call, then brackets again. Let's change this function here to be asynchronous because we are awaiting an action. Asynchronous, yeah. So let's see if it's going to work up to that point. Let's see. I haven't implemented the action for that in the front end, but let's see if it's displaying something here. Let me here say display the counter and see if it's going to display. See, oh, it's not defined reference. Let's see. It's supposed to keep this. I've written counter. It's kinda. Let's refresh and see. Yeah. Combination state this. Set get counter. Let's see where the problem is. the console. After where is it? Get count. Where is it? Oh, sorry. I forgot to do this. Yeah, we set the counter. Is it set the counter to result dot to string so that you can be able to see it in form of a string. Yeah. This one. Let me also add this comment here. This is now to make it visible in the front end. Now let's go and see. Oh, so I've forgotten. I didn't do this. I'm wondering why. On the ear, I should call that function. Sorry. Again, I forgot. On click. On click. Now that when you click this button, it's supposed to perform this action. What's the name of that function? We call it get counter. Yeah, that's the name of it. Get. Yeah, like that. It doesn't. Let's refresh again. It's taking a while to respond. Yeah, you see now it has gotten the number here. Yeah, from the number we deployed on the blockchain. Now it's getting the counter from 500. Yeah, that's the first step. So I think up to there we have interacted with the first function. That's the reading functions. Reading function. So the other ones are now writing functions. So writing functions, how you going to implement them? The first one is increasing. Look in increasing function. So it's also going to be a function. Also, it's also still going to be asynchronous. So let's start like that. Asynchronous function. Yeah, let's call it increase counter like that, and then like that. Then inside increase counter, the first thing you need to perform now, because you are now interacting with the blockchain, you have to confirm that your wallet has been connected. By the get counter, you're interacting with the blockchain, but you necessarily don't have to be connected to have to be a wallet connected, because you're just reading from the blockchain. But for you to update the blockchain, you have to have your wallet connected. So that you need to confirm that confirm or let's say confirm or connect connect your account. that is wallet. Yeah. So for you to do that, you start by writing const, yeah, and then you can say you can know the accounts connected, because I remember I told you, I also talked about this in the previous classes. In one MetaMask account you can have various wallets. So yeah, that's the main reason for that. So you need to check all the, like, in one MetaMask account, one MetaMask wallet, you can have various sub accounts for different purposes. So you can check the ones that are connected. You can say is equals to await, because you're awaiting some actions. Web3, where is Web3 dot e, yeah. Then if you are connected or not you are not connected, you call the, okay, yeah, like this, request accounts. Where is it? Yeah, request accounts, like that. Not there. Yeah. By this action here now, you're able to interact with you're able to see if your wallet is connected or now. The MetaMask will pop up if you have not connected. If you interact with the increasing and decreasing, it will first have to check if you are connected or not connected. If you're connected, it will proceed. If not, it will prompt you to connect now, from scratch now. Yeah, now after that, now the increasing function. Yes, you can say now const we can call it transaction. Let's call it transaction. Yeah, because it's a transaction of checking we are performing. So we await my contract dot method dot increase with increase counter dot send. Now here let me write, and then I'm going to say something. Dot send. Before even I proceed, you can see when now here in the, where is it, the get counter. When you get the get counter, where at the end you're writing dot call, because they're only calling that action or that function. But here you're writing dot send because you're sending a transaction on the blockchain. So when you're writing dot send, there's some things you need to specify. Dot send, and then you open the square brackets, and then you also open the curly braces and say from, then you check the accounts connected with the accounts connected, the accounts, the first account zero. Yeah, if you know from programming, you start from zero. Yeah, okay. We can console log the information. We see if you're okay up to this point. And transaction. And also we can, because we are using new state, we can also call the get count again for it to update the value of the number here when you call it again, because it has to be updated automatically. So after that, we can go to the button here for increasing. What is it? Increasing counter, and say on click. Yeah, on click. It calls the increase counter. Where is it? Yeah. And yeah, refresh. When you get the current counter, yeah, it's 500. When you click on increase counter, MetaMask is, oh yeah, it has popped up at the side here. Yeah, here it is. Let's wait. Anyone? Yeah, let's confirm the transaction. Yeah, it does say some gas fees here. After we send that transaction, let's wait and see. Oh, I initiated it twice, I think. Let's just confirm it again. I think it will initiate twice. Let me just confirm it again. Yeah, you see it has incremented by one here now. The value has incremented, and it has displayed here. It has incremented by one, and because we console logged twice, and you can see the information of the first information here. Everything, yeah. If you look more, you can see use it from, yeah. This is my wallet address here. You can see, and the action that we performed here. Okay, so the last thing that you have remained with is implementing the decrease function. So the last thing we have to do is also, you can say, okay, we can copy even the same code here. No, let's just write it. But you can just copy it and change here, like increase counter, degree increase counter here, and change it also. Yeah, basically that. But let's just write it and say it's an asynchronous function again. It's an async function that it's called decrease counter. Yeah, like that. Okay, decrease counter. Again, you check, you confirm or connect your account, that is the wallet. By doing that, you do const. Basically, you're doing the same thing as above here. Const. Let's use another name, connected accounts is equals to await web3.e.request accounts. Yeah, basically up to that way. And now the next thing now, it's now the decreasing function You can say again const, let's say transaction again. Let's call it transaction is equals to you await my contract dot method dot let's say it's called decrease counter here dot send brackets curly braces from again the connected accounts now connected accounts that is in the array zero, like I mean like the first one. Yeah, like that. Yeah, you can console log the information, and also there's no need of console logging here. Let's just remove it that we were here. After that, now you just update the get counter again because we need to update the state. Yeah, and I think we're done. If you come here and let's refresh again. If you get the current counter or the current number, it's 502. Yeah. If you now try to decrease it, oh sorry, I didn't call this function here. At the button here, call it on click is equals to decrease counter. Now if you click on decrease count, yeah, just work. The MetaMask is coming up. We are decreasing the number. It was 502. Let's wait and see if it will decrease. Yeah. And now let's get the count. It's supposed to be because you have decreased it by one now. Let's see. Has it performed that action? Yeah, it has reduced. Yeah, you see, it's now 501. Okay, I'll stop there unless anyone has a question. Anyone who has a question before about everything that I've done so far?